Hello and welcome to a very long patrol. This is Blackburn Aircraft of the 1920s and 1930s. So, settle in because this is going to be a long one. And I'm going to say now, if you like it, please do subscribe. Please press the bell to get updates when there are more out. And if you feel like becoming a patron so you can get a look at these slides closer up, that's always very, very much appreciated because that money all goes towards me buying more books. And I do love my books. So, we're looking at Blackburn Aircraft 1920s, 1930s. And this all comes about because of a guy called Robert Blackburn, who's the son of, well, another engineer who makes lawnmowers and steamrollers and other things like that. Who has all sorts of academic training, and you can guess what he comes back to the family firm, doesn't quite fit in anymore. Goes off, travels around Europe, gets into flying, comes back in 1908, wants to build an aircraft he has designed. The family firm doesn't want to do it, so he parts, but his father does give him the money and financial backing to set up a small workshop of some 5,000 to 6,000 square feet beneath a clothing factory in Benson Street, Leeds. He was also sent a young apprentice called Harry Goodyear. You've all probably heard of that name. Who was one of his father's apprentices, to come along and assist. The monoplane was completed quite quickly in April 1909. Blackburn took it in a horse-drawn furniture removal van to the stretch of sands between Marsac and Saltburn and began attempts to make it fly. Even at this early stage, he was assisting other experimenters by specialising in the manufacture of wooden air screws in the Benson Street workshop. At 35 shillings per foot of diameter, and early in 1910 put an advertisement in the technical press offering to build complete aeroplanes with either hand or patented automatic control at a price of £700. Eventually, on 24th May 1910, he broke his first monoplane without having flown in the true sense of the word, and returned once more to Leeds. Harry Goodyear's suggestion that he should now go back to Green's and get on with some real work was countered by a request that he stay on and assist in the construction of a second, more conventional aeroplane. Its design was undoubtedly influenced by what Rob Blackburn had seen in France a year or so earlier, for the aircraft bore a marked external resemblance to M. Levasseur's Antoinette monoplane, even to the small twin triangular rudders, one above and one below the elevator. These eventually became an identifying feature of many pre-1914 Blackburn aircraft. Never idle, Blackburn also made known his readiness to build aeroplanes to customers' own designs, describing himself as Blackburn Aeroplanes of 18 Spencer Place, Leeds, and offering his second monoplane, later known as the light-type monoplane, to distinguish it from its predecessor, for sale at £500. It's early days, and it goes on to form a company. In May 1914, the Farnborough-designed BE-2C was adopted as standard equipment for both the RFC and the Royal RNAS, that's the Royal Flying Corps and Royal Naval Air Service, and the Blackburn Company became one of the several subcontractors when initial order for 12 was received from the Admiralty. Up to that time, the company had been financed by Robert Blackburn personally, but faced with a series production and the need to maintain larger premises, he formed a limited company, formally registered in June 1914 as the Blackburn Aeroplane and Motor Company Limited, with a capital of £20,000 in £1 shares to acquire the business of an aeroplane designer and constructor carried on by R. Blackburn as the Blackburn Airplane Company. First directors were Robert Blackburn and J. E. Jackson, with a Stuart A. Hurst, the well-known local flying enthusiast and patron, as chairman, and Stephen Blackney, for years an engineer on the London and North Western Railway, as works manager. This is a fun, amazing little company. They had already taken possession of Olympia, a disused roller skating rink in Roundby Road, Leeds, and had erected their first biplane, the Blackburn Type L seaplane there. It was followed by larger and larger batches of BE-2Cs. They also built Harris Booth's AD Scouts and developed the Sopwith Cuckoo torpedo bomber and the Sopwith Baby seaplane, which they built in quantity for the Admiralty, as well as the TB triplane, GP, and White Falcon prototypes of their own design. Although these government contracts gave financial stability to the firm, Robert Blackburn was more interested in developing his private venture seaplanes, and by 1916 felt that the time had come to establish a base equipped to handle these machines. In consequence, Mark Swan was dispatched to select a suitable site, which he soon discovered beside the River Humber, adjacent to the main Leeds-Hull railway line, at the village of Brough, where there was space for an aerodrome, easy access to the river from marine aircraft, and according to legend, a couple of country pubs, the Ferry and the Station Hotel, the excellence of whose beer was a deciding factor in subsequent negotiations. Establishment had no sooner been completed than the government commandeered it as base for No. 2 Marine Acceptance Depot and built what later became known as A Shed and the Fire Shed, or North Sea Hangar. It was first used for the final erection of short 184 seaplanes by Phoenix Dynamo Manufacturing Company Limited, and brought there from 1916 onwards from Bradford for launching. These were followed by the Phoenix-built prototype P5 Cork flying boat N86, which was launched on the 7th of August in 1918. They managed to make it through the lean years and chase Schneider trophies, like Supermarine, and then get into building increasingly more and more maritime types. Brough becomes an important place, as does many of the others, and this is what Brough looked like. They slowly take on more designers, more engineers, and they get bigger and bigger. The genesis is the Blackburn T.1 Swift. This is what starts the company really off as a name of its own in operating things for and producing things for the Naval and the Fleet Air Arm. Although, to be fair, he says this and he can't find a Swift. There it is. The Swift is produced as this... how do I put this politely? Well, it's a private venture. At the end of 1919, after the short shell and Blackburn Blackbird had been found unsuitable, the Air Ministry issued its requirement for a carrier-based torpedo carrying Sopwith Cuckoo replacement. This was to be a single-seat torpedo bomber. Yes. The first torpedo bombers were just pilots only. They were short-range aerial destroyers, more like short-range aerial torpedo boats. And you can see this. It's got a 450 horsepower Napier Lion 1B. It's got a 48-foot 6-inch span. It's got an all-up weight of 6,300 pounds, which is really not that much. In fact, it's definitely not that much. And as time would go on, they'd use it more and more as a test bed, trying it out with various different engines and various different systems. to an extent, the Swift becomes a constantly working prototype. And yes, I am going to try and get away from my notes, but with about 16 aircraft to cover, I am going to rely on them at some points. The Swift is in early development. It isn't successful. It doesn't get selected, but it starts them off thinking this could be something they could do. And it is such a good contender that it does get other options. One of the interesting things about it is that because it's only really ever a prototype, it only really ever gets armed with a torpedo. It doesn't get fitted with machine guns. There's all sorts of lovely stuff on various sites about the internet about it being fitted with a single machine gun, this or that, and the works notes in this book, and the book I'm using, I'm going to get to in a second, are very emphatic that whilst it was designed for, because it was a prototype and they were primarily interested in torpedo. Dropping a torpedo was its primary duty. Having a machine gun was something nice, but it wasn't supposed to be a fighter. This was supposed to be an aircraft which was going after ships, and the concept of air defense at sea involving fighters and all these things was a bit up in the air. A maximum speed of 106 miles per hour with torpedo, and a range of 350 miles. So that translates to a strike range of 175 miles. If you're going at maximum speed, well, it's a little over 3 hours flying time. But no, it wasn't selected. But it has an important thing. And I specifically haven't listed it there because I wanted to emphasize it. It can fold its wings. The storage. And they can be folded. They start off at 48 foot 6 inches span. Folded, they go down to 17 feet and 6 inches. But the various projects, there's one produced for the Royal Navy, the Swift T1. There's also two for the US Navy sent over there. They also don't get machine guns. An aircraft goes to America, it's given to the US Navy and doesn't get fitted with guns. And 5 aircraft, 2 for the Japanese Navy, 3 for the Spanish Navy, are also delivered. They also plan a Swift Mark IV, which would be a 10-seater airliner aircraft, and looks very much like a Blackburn Blackburn, but we won't get into that for now. We'll move on to the sources. So, sources for today are the British Aerospace website, the British Aircraft Specifications file, Blackburn Aircraft by A.J. Jackson, and Fleet Air Arm Aircraft Units and Ships 1920 to 1939 by Ray Sturviant and Dick Conine. But that was mainly a quick glance to check the squadrons were right, squadrons and flights were right, as was another book of the Fleet Air Arm Squadrons by Rick Sturviant as well behind me. The main books are the ones pictured, and especially this one and this one. If you see a specification, it's been taken from here. Occasionally the wording has been slightly modified because it starts off referring to other types of aircraft and other things, so I've added in explanations. They're things they didn't need to put in the specifications because they didn't need to put them, because everyone knew what that previous aircraft was. But if I haven't got the previous aircraft from another manufacturer in here, which I'm not, I have to presume. So I add in the explanations. I also explain some of the alloys they're using and exactly what they're made from. And if the characteristics of the aircraft and the first shot of the squadrons, they're then checked, or flights, and they're then checked in those other books, comes from this book. So, Napier Engines. Earlier we were talking about the Swift, and that, of course, if we just remind ourselves, has a Napier Lion IB 1B, 450 horsepower variant. Now, that's quite a common engine. That's quite a common type. Napier are a very major engine manufacturers, but as a rule, you'll more often than not hear about Rolls-Royce than you will about Napier, because Rolls-Royce are the ones that are still going today, and they're just a massive name. But very much Napier and Rolls-Royce were the equivalent at the time. There's also, of course, Bristol, who are very much famous for the Pegasus, who were, to be honest, the leaders in air-cooled engines. But if you're talking about a liquid-cooled engine, you're talking Napier, you're talking Rolls-Royce. Air-cooled, Armstrong Siddeley, Pegasus, and Bristol. Sorry. But one of the myths that goes around is that the reason that the aircraft are slow because they can't get engines with sufficient horsepower. Actually, engines with sufficient horsepower can be made to make them faster. Engines are, the power-to-weight ratio is one of the biggest governing factors of aircraft speed in this period. But engines weigh a lot. It's power-to-weight ratio. And so if your engine gives you 1,000 horsepower, that's great. But if your aircraft is going to weigh less than 10,000 pounds, and your engine will weigh alone nearly 2,500 pounds, as the 1919 Napier Cub does, when dry, i.e. no fuel, nothing going around it, that's 1.1 tons. That's pretty darn costly. Merlin 2 generates 1,030 horsepower. It's about 15 years later. but it's 1,320 pounds. Okay, that's still 0.6 tons, but that's half a ton lighter. That's a lot. And it's still generating your 1,000 horsepower. There is an aircraft built off using it though. For that particular, in fact there's a couple, there's a Handley Page one as well. But the really big one which we can talk about is I'm looking for the good picture of it. Because 6 of those engines are bought by the Air Ministry for £10,000 an engine. That's another reason it doesn't catch on, because, as you heard earlier, aircraft aren't that expensive. Well, they don't want them to be that expensive. They are expensive, but they don't want them to be. And the Cubbaroo is colossal. It is glorious, but it is colossal. And it's all about them trying to find a way to use that engine. That is the Cubbaroo. You'll notice it has 2 sets of undercarriage. 2. It is a truly colossal aircraft. You start to read things like the Cubbaroo has the 1,000 horsepower Napier Club, and then later the 1,000 horsepower Beardmore Simoon Mark 1. Eventually they'll also try it out with 2 650 horsepower Rolls Royce, which, believe it or not, managed to displace less on the aircraft than the Beardmore Simoon. And it was an early attempt at a land-based torpedo bomber, because that was how they were justifying it. Because torpedoes are that heavy. They displace that much. So, we've covered engines. Now let's cover aircraft. And I'm going to disappear for a second while I talk about this, because, honestly, this is complicated. Ah, it would do. Wooden air screws. Propellers, to people who are just looking at them, are made by 3 main ways. There are different techniques, but Blackburn actually starts off, as we talked about, making their own making air propellers for everyone, and usually are associated with what is known as the weighbridge blade. This blade, made by described this one as one made by the Airscrew company, I'll tell you, is carved frail, blank glued from boards of Douglas fir, scarf joined at the roof end, to jickwoods or to similar Nenkerbregs, supplied by firms in the United States. Jickwood, supplied by the firm Jiquid, associated with Airscrew Company, is prepared by coating Canadian birch veneers with about 4% by weight of a spirit-soluble pneumonic resin, drying and then consolidating the pack under heat and pressure. The resin content and the conditions of pressing are such the jiquid is not stabilized appreciably either by the resin or by the action heat of moisture. The blank is rough carved by machine and then finished carved and balanced by hand. Due principally to the time required for conditioning and various stages of manufacture, the elapsed time for a blade in production is 7 to 12 weeks. All three styles are used at various times by Blackburn, but basically they all come down to most wooden propellers come down to you either have the option of producing your propeller from a single piece of wood, which produces a very solid but also a very problematic in many ways because it's actually more prone to warping. Or you produce something which is closer in idea to plywood, in that using resins and different pieces of wood, sometimes different types of wood, you build up layer by layer your propeller. And you have to join and jig it all together and heat resin compacted. It can produce a very beautiful blade and a very useful and functional system. It is one of the critical advantages of especially naval aircraft from the British perspective. 1970s and 1930s using these propellers because they are incredibly forgiving. They will take a lot of damage and they're quite easy to repair. Often. Because they have quite a lot of strong, they're quite strong. However, there are of course advantages in other systems in that you can be more precise about their balancing. If it's the trouble is with wood is it's not, and it needs to be balanced so finely that if it is not quite perfect, it can produce its own pitching on the aircraft. So you have to be very careful. You have to be absolutely sure it's perfectly balanced. If it's done well, it's one of the best propellers you can get. It probably is arguably the best propeller you can get in the 1920s anyway. The earlier mechanical non-wooden ones were interesting, let's say. 1930s, it's still up there. Even World War II, it's still up there. If you're doing a propeller-based aircraft, if you're doing sort of that as your primary piston rather than, if you're doing a piston-based aircraft, piston engine system, yeah. Turboprop, you want it to be variable pitch, so you wouldn't want wooden one. And jet, no, but you know. Anyway, now we're getting into the proper ones. We're getting into the ones which start to actually get orders. Dart and the Rippon. So the Dart is special. The Dart is produced Air Ministry Specification 320, seeking a single-seat torpedo-carrying land plane fully equipped to Admiralty requirements for carrier operation. Later, twin-float seaplane and second cockpit dual-control versions were also required. The Blackburn Dart experimental aircraft evolves from Air Ministry trials on the modified Blackburn T.1 Swift prototype. in 139 and led to the placing of a contract for the Swift with a reduced wingspan. Basically, they liked the fact that it folded. It made a lot of sense, and there were a lot of people going, ooh, we like this. But the fact is, the full wingspan was still a bit much. So the wingspan for this is, yeah, just checking, 45 feet and 5 3/4 inches. Which, if we quickly go back, 48 feet and 6 inches. So it's dropped 3 feet and 1/4 of an inch. Which doesn't really sound like much, but it makes a big difference. It does. It really makes a difference when you're organizing your aircraft, when you are arranging them on a flight deck, all these spaces. That helps. The military load has gone up. The capacity is primarily for the pilot. It is primarily a single-seat aircraft, as the Navy procured them. And they equip number 460 flight on HMS Eagle in the Mediterranean, 461 and 462 flights on HMS Furious as part of the home fleet, and 463 and 464 flights on Courageous in the Mediterranean. They are powered by a 450 horsepower Napier Lion 2B or IIB, or a 465 horsepower Napier Lion 5 or V. All up weight 6,383 pounds, including a military load of 2,140 pounds, and have a maximum speed of 107 miles per hour at 3,000 feet with torpedo. Not going anywhere too fast, and a range of 285 miles at 95 miles an hour, which is that cruising speed. This is just a proviso as going forward. If I don't give a height for the top speed, the maximum speed, then it's sea level. Okay, it's as low as it can go. And yes, aircraft with their engines, their adjustment of the pitches, can actually be slower at certain points than they are in other parts. Sometimes they respond better to where the air is thinner, sometimes they cruise better where the air is thicker. It really does seem to be, in this time, more of a factor to do with, how do I put this, the way they design, especially the biplanes, the wing structures. This can have an effect on their performance at various altitudes. For example, some are designed with a larger top plane, and the bottom plane, top main plane is larger, and the bottom main plane is thinner. Some are gull-winged at the bottom, some are gull-winged at the top, and some will have various forms of strutting between them and weights, and it's all quite cool. An event of more profound and lasting importance took place on After Dark on the 1st of July 1926, when Flight Lieutenant Gerard Boyce touched down on Furious in N9804 to demonstrate the feasibility of night landings on a carrier at sea. This is where the Dart is really important. In 1926, they carry out their landings at sea at night. In a few years, night flying from carriers became a normal operation, and at fleet exercises held in 1931, the Darts and number 463 flight from Courageous were redoped in night camouflage. This flight and its companion, number 464, each equipped with 6 Darts with Lion V engines, embarked on Courageous when it was commissioned on 21st of February 1928, and after a working period during which the first deck landing was made by Squadron Leader S. Watkins in a Dart, sailed in it for the Mediterranean on the 2nd of June. Malta was reached on 10th of June, and next day both flights were flown off to Hal Far Aerodrome. But in the first ever takeoff from the deck of Courageous, Lieutenant Nicholas R.N. was killed when his Dart struck the superstructure and went over the side. Crews reached a high pitch of efficiency, and in a fleet and air exercise held off the Isle of Wight on the 9th of September 1930, a combined force of 15 darts of numbers 461 and 462 flights based on Leon Solent then scored 8 hits on the battleships Nelson and Rodney. Attempts to shoot them down were invariably foredoomed to failure, as, when pursued, they slowed right up and took evasive action at a speed well below that at which any fighter could stay in the air. What does it sound like? They're just cool aircraft. I have a lot of affection for the darts. I have to put this in here next because I have to save this next book, a chapter, because, well, we'll be coming back to it. From now on, let's see what's next. The T.3 Velos, produced for the Greek Navy. It's basically a Dart, but modified, because you have this beautiful, reliable aircraft, but the Greeks want something more. They want something capable. They want something which will allow them to operate far and wide, and preferably scare away the Ottomans, or Turks, who they keep having trouble with. And also, their other neighbours, they're not quite sure about them, and all a bit iffy. So, yes, they need something capable. They're not going to have an aircraft carrier, but they want to have air support wherever they can get it. So they want a seaplane. And this changes the Dart, because the Dart is a land plane which can, a deck landing land plane, which can become a seaplane. The Velos is a seaplane which can be used on land. And this is all giving Blackburn development. They are getting stronger and stronger when it comes to producing reliable aircraft. The fact that they were used for night landings and all these things is because they are reliable aircraft. And this is what the Royal Navy is looking for. It's looking for reliability. This is something which comes back to bite them later on, but we'll get into that. The Rippon. See what I mean about a gull wing? Yes, and I thought I'm sure many people thought that it was just a Corsair which got them. No, it wasn't the just Corsair. Here is the T.5 Rippon of 1923 with a beautiful gull wing. And this is a slightly more complicated aircraft when it comes to its factors, so I'm going to expand it a bit. So I'll see you in a second. Produced the Specification 2123, the two-seater torpedo-carrying ship plane for fleet use. The Air Ministry was seeking a replacement for the Blackburn Dart to carry either an 18-inch torpedo or a free 520-pound bombs over a relatively short range. In addition, 12 hours endurance was required when the aircraft was on reconnaissance duties. Other requirements included folding wings to facilitate hangar stowage, interchangeable wheel and float undercarriage, the provision of shipboard equipment such as flotation bags and arrestor gear, and the specification was intended to include an additional requirement for short-range bombing. Now, the Rippon is a crucial aircraft in the development of Blackburn, in the development of naval aviation. You can't doubt that one. But the stats given are for the Rippon 1 and the Rippon 3, which are Genesis and the starter it. But the major one is actually the Rippon 2A, and there's a reason I left that off. Now again, you'll notice it's the same flights, the 460, 461, 462, 465 and 466 flights, which are getting these aircraft. And there is a habit developing in the RN that they are, in the Fleet Air Arm, under the Air Ministry and RN leadership, that often flights, when they upgrade, will upgrade to aircraft from the same manufacturers. To keep as many manufacturers going as possible. The Rippon 2A has a upper span of 44 feet 10 inches, but a lower span of 45 feet 6.5 inches. Yes. You are hearing me right. The lower wing is longer than the upper wing. The folded span at that point is 17 feet and 10 inches. The land plane length is 36 feet 9 inches. The land plane height is 12 feet 10 inches. And the wing area is a total of 683 square feet. In all up weight, it's 7,282 pounds, able to carry a military load of 3,150 pounds. It's got an endurance of 4 hours. And is fairly capable in this form. However, with some modifications, its range of a torpedo was increased 815 miles. Its range in reconnaissance was increased to 1,060 miles. It still had a military load of 3,150 pounds. But with a speed at 5,000 feet of 118 miles per hour and a speed at sea level of 126 miles per hour, which was their top speed, they were considered fairly capable. And actually were eventually, if they were going very, very slowly, which they could manage, they could keep up the endurance of 12 hours. But that was a fairly difficult one to get to, if you're also designing to carry a torpedo at this point in the technological development. But for those of you who are thinking, wow, those stats and those requirements sound very similar to the aircraft which dominates World War II in quite a lot of popular memory, the Swordfish. Well, as you'll be seeing as we're going through, pretty much as torpedo bombers go, the Royal Navy orders the Dart, well, the Air Ministry orders the Dart on behalf of the Admiralty for the Fleet Air Arm in the early 1920s, and then reorders it as the Rippon, and will reorder it again, and again, and again. It's getting slightly better each time, but it pretty much keeps ordering the same aircraft, and it's doing the same with Fairey reconnaissance aircraft, which might explain why the Fairey 3 lasts so long in service, because they're basically just asking for the same again. So, at the same time as there are all sorts of developments taking place, the Fleet Air Arm is getting very, very good at its operations. And it's getting good at its operations in large part because the aircraft it's ordering are the same aircraft. So instead of it having to really, they are better and refined and they are more capable versions of the same aircraft. Which means that instead of them having to almost relearn every time they get a new aircraft, they're able to keep building upon the techniques. Hence they get quite so good at night flying. But also there is an emphasis coming through on range and endurance and reliability. Well, it wasn't just the British who liked the idea of range and endurance and reliability. Believe it or not, it was also the Japanese. And the Japanese thought, well, we've got two options in this scenario. We can develop it ourselves, but which will take a while, or we've already had Blackburn planes before. Let's order ourselves another one. Now, this is done in early 1927 because the Imperial Japanese Navy decides to replace its B.1 M.1 Type 13 carrier attack bombers. So it issued the specification to Aki, Kawanishi, Mitsubishi and Nakajima companies for a new carrier-borne torpedo bomber with long-range reconnaissance capability. Mitsubishi, to improve its chances of securing a lucrative contract on which would depended not only its reputation as the leading Japanese naval aviation aircraft manufacturer, but at that time its very existence, took the unusual step of bypassing its own design staff and requested basic layouts from Herbert Smith, a former Sopwith designer, who had been responsible for some of Mitsubishi's earlier designs when in Japan in 1921, and from the Handley Page and Blackburn companies. One prototype of the winning design was to be built in England under the Mitsubishi designation 3MR4, which, as you see, I've explained what 3MR4 stands for. 3 is the number designated for its primary duty, torpedo. Manufacturer, Mitsubishi M. Secondary duty is reconnaissance, so that's given a letter. And then generation. This will be the fourth generation of torpedo bomber. They first stipulate that it's going to be a 600 horsepower V12 water-cooled Hispano-Suiza type. But that itself gets upgraded to a 625 horsepower Hispano-Suiza before it actually is tested. And the actual production model is a 650 horsepower Mitsubishi Hispano Type 7. Because Mitsubishi buy the template from the Hispano-Suiza and the right to produce it locally. Right, they're buying this aircraft. And then they can play around with it and upgrade it themselves. It's capable of a range of 1,100 miles at 112 miles per hour, which is fairly good. You will notice it hasn't got a gull wing though. But it is beautifully streamlined. And it's got a lovely wooden propeller. Up to 3 crew. 7.7mm machine guns, the Japanese variant. The equivalent of the .303 inch. And can carry an 800 kilogram or a 1,764 pound torpedo, or equivalent weight of bombs. So it's very similar to the Dart in its capabilities, but this is referred to as the T7B by Blackburn. It's referred to as the B2M by Mitsubishi, and the 3MR4 by the Japanese Navy. Just to confuse everyone. It's really fun researching this one because it was really, really interesting trying to work it all out. But eventually, I got it down to on the Kaga in 1937, serial numbers 301, Akagi, 1937, serial numbers 303, and Ryuju, 1937, serial numbers 312. They're produced between 1933 to 35 mainly. But it's sort of interesting how long they are and how long they're in service for. But they're a cool aircraft. They are a very cool aircraft. And it's Blackburn developing and spreading its reliability again and getting very good with its reliability. And they really are getting good with their reliability. The Baffin and the Shark, Part 3. But it won't start with a Baffin. It'll start with this. And I have done a 2-minute on this one, but I'm going to expand it and I'm going to go through it again. Specification M.1 continued in S1533. It's the torpedo bomber ship plane, and this is the beginning, in many ways, of the story which would end up with the Swordfish, but it would go via several Blackburn aircraft on the way. Specification is issued to govern the production of a 2-seat torpedo bomber ship plane designed for fleet use to carry a 1,866-pound Type K torpedo or a 2,000-pound bomb load with a maximum all-up weight of 9,300 pounds. Remember again that Cub. If you were trying to go for a 1,000 horsepower engine in 1919 on that would have been problematic. Performance: the speed at 4,000 feet, with the engines running at maximum permissible RPM, is not to be less than 130 knots. The landing speed is not to exceed 55 knots. The service ceiling is not to be less than 16,000 feet. The tanks permanently included in the fuel system shall be large enough to hold fuel for half an hour at full throttle at sea level, plus 7 hours cruising at 100 knots at 4,000 feet, while carrying a military load of 2,874 pounds. The capacity of the oil and reserve water tanks shall be sufficient for 8 hours cruising at the above conditions. And please note, military load doesn't just include ammunition. It doesn't just include bombs and torpedoes. It also includes ammunition and any other special equipment which might be needed to carry to fulfill the role. The aircraft, when flying in its fully loaded condition, shall have positive stability in all axes, respond quickly to the controls and be fully controlled at any speed, especially near the stall and during the steep dive, when it shall have no tendency to hunt, i.e. please, we want this to be a very accurate dive bomber if necessary. We don't want it to start going off going, ooh, I fancy that patch of water over there, not the ship you're aiming for. Be reasonably easy to manoeuvre, not tiring to fly, form a steady platform for bombing and firing at any speed within its range, not experience excessive fluctuations in the speed for which it is trimmed if the throttle control is moved from the correct position for that speed to either of its limiting positions. In other words, even if we put a dunderhead at the controls, please don't have any problems. Don't want to put a dunderhead at the controls, but these things happen. Or maybe he's a very bright young pilot, but is injured, in which case he's doing a dunderhead maneuver. The design of the aileron or control system is to be such that operation of the ailerons with produced the minimum of adverse yawing effect on the aircraft. A slot device of an improved type or some other approved means of ensuring adequate lateral control and stability at the below the stalling speed is to also be embodied. Any suitably rated type of British engine which has passed the 100 hours service type test may be used. Suggested types are the 825 horsepower Armstrong Siddeley Leopard, an air-cooled engine, or the Rolls-Royce NH10, a water-cooled engine, with a metal air screw. Ouch. That's bad for poor Blackburn. They still prefer the wooden ones. Materials. All parts of the aircraft which contribute to its strength in the flight are to be made of metal. Each metal part in the structure of the aircraft is to be protected against corrosion by whichever of the methods stated in ADM numbers 160, 190 and 193 is applicable. Basically, cover, cover and cover. Accommodation. The crew of 2 are to be accommodated close together to ensure adequate communication between the pilot and the bomb aimer's prone position, i.e. when the person is down on the floor trying to line up the bombs, let them be within shouting distance of the pilot. A good field of view is also required. Well, that makes sense. Maximum dimensions are span 50 feet, length 44 feet, height 100. I'm fairly sure that's supposed to be 14 feet. I do apologise for that. I hadn't noticed that at all. And a folded width of 23 feet. One type alternate weapon loads are required are one type K or Mark 8 or Mark 9 torpedo, one 2,000-pound bomb or one 1,000-pound bomb, two 520-pound bombs, 8 230-pounds or 250-pound bombs, plus 4 20-pound practice bombs in each case. I'm not sure why you'd be carrying 20-pound practice bombs if you're carrying a 2,000-pound bomb. I honestly, it's kind of the effect of going, you know what? I've just dropped a whole stick of dynamite with you. I'm going to set put a party popper down there as well. There isn't really much advantage to it, but yeah. And effect, it's probably for when you're carrying the dummy butt versions. That potentially makes sense, but still, it's a bit of a An effective torpedo installation is not to be prejudiced by the provisions for a 2,000-pound bomb, i.e. the bomb has to make way for the torpedo, not the other way around. A fixed forward firing gun and provision of a single gun station aft of the main planes is required. Avro, Blackburn, Fairy, Handley Page, Supermarine and Vickers all submitted designs for this. The Blackburn, Handley Page and Vickers designs are the only ones which survive. The Fairy one we can be fairly sure doesn't look too dissimilar to the TSR they submit for another specification for a spotter reconnaissance aircraft at this time, and that's of course what becomes the Swordfish torpedo spotter reconnaissance aircraft. But that is a while away and about 2 specifications, including S1533 away. But one of the things you do notice as you're reading through this lovely book is that the specifications are getting more prescriptive as time goes on. They are getting more detailed. One of the very interesting things is that at certain points, as there are fights going on, there's a great debate over control of the fleet air arm, over whether or not the Admiralty should have its ability to order its own aircraft, have its own technical expertise, and a full control of the fleet air arm, or partial control of the fleet air arm, all these things going back and forwards. Things start to develop, and eventually there becomes a halfway house, which is operational requirements. I.e., the Admiralty can issue an operational requirement which pretty much dictates what they want as an aircraft, and then the Air Ministry has to order that. It's a sort of one of those halfway houses, but the Air Ministry still gets to advise and heavily influence the selection of what aircraft is chosen for it. But at this point, in 1930 and 1933, the Admiralty and Air Ministry are still very much trying to cooperate together with each other. Now, the specification produces the B3. The B3 isn't powered by either of the recommended engines, because by the point the specification comes out and the aircraft are ready, all sorts of engines have passed. Remember, they only have to be given 100 hours running, so you turn the engine on and you keep it running for a week. And you can do that. Blackburn do that to their engines themselves before they fit them. In fact, they do it longer. One of the systems which Blackburn has got set up at their Brough factory is a stand where they can hook an aircraft engine up to controls and a huge fuel tank, and they have technicians on duty in a nice, well, basically it's a little shed, but let's be honest, it's fine. They're far enough away from the aircraft, but they're controlling the engine, and they just run it. and they leave engines running for an entire week. For 2 weeks, they will have them running 24 hours a day for that entire period. Now, yes, some engines do blow up. Some engines have all sorts of fun. But it's a good way of testing the engines and just keeping them running. Just seeing what faults develop, seeing how they get through and how you can fix them. And the aircraft companies do work with the engine companies. They do work very closely with them. Because they both want the best. So, the Blackburn was based on this project dated 12 September 1988 for a 50-foot span biplane with Rolls-Royce, originally with a Rolls-Royce XII engine. So that's the F12 engine. To specification M528. And it's basically an all-metal Rippon. Believe it or not, they keep lots of specifications keep coming around. I could read M528, I won't. It doesn't really tell you much more than M130 does. But they keep working on it, and eventually they come up with, as a result of how they start off with the M130. It doesn't work that well, and then they produce the M138A. As a result of experience gained in constructing the M130, Blackburn went ahead with the construction of a private venture which they called the M130A, which differed from the original in three important respects. Span and chord of the lower main plane was reduced, cutting total wing area by nearly 76 square feet. The fuselage was of all-metal, semi-monocoque construction, with transverse ring frames at 2-foot pitch connected by intercostal stringers, and 4 freeze-type ailerons were equipped with operating gear of new and unique design, which enabled them all to be depressed by means of a hand wheel in the cockpit to act as a camber-changing flaps. This is important if you are going to be flying slow and low. The decking behind the observer was made removable to accommodate a separate gunner whose weapon, when not in use, lay retracted in a groove in the fuselage, as on the Blackburn Rippon. The entire fuselage was alcad covered and divided internally into watertight compartments, which gave far greater reserve buoyancy than old-fashioned flotation bags. Now, alcad is an aluminium-copper alloy. It's all the rage at this point, and I'll get more into it in a bit, but it really is important for aircraft design this time. The most radical change, however, was to be found in the centre fuselage, which was built of stainless steel and sealed by riveted and soldered joints to form a fuel compartment which occupied the whole space below the decking, between the pilot's cockpit and the front watertight compartments. Separate tanks suspended within the fuselage structure were thus dispensed with, and the stainless steel container was divided by bulkheads to provide a 135-gallon main tank, a 100-gallon rear tank, and above them a 22-gallon gravity tank into which fuel was pumped en route to the engine. Each tank section was fitted with a large manhole through which maintenance staff could insert head and shoulders for inspection or repair of the interior, and the whole installation was considered more accessible and efficient than 3 independently installed fuel tanks. This is important. This is an important design point, because you are not going to get that 750 miles range, all those things, if you do not have it organized properly. The M138 also differed from the first aircraft in having long perforated extension exhaust pipes from each cylinder block, automatic wingtip slops, and 1095mm x 250mm heavy-duty Palmer type tyres, and pneumatically operated brakes, the reinforced rubber air bottle for which was located inside the forward water compartment. Armament consisted of a fixed forward-firing Vickers Mark II machine gun in a tunnel on the port side of the front fuselage, and a 303 Mark III Lewis gun on a high-speed rotatable mounting over the third cockpit. Racks were provided on the main planes for 4 550, 520 or 500-pound bombs, 8 250-pound bombs, or 8 20-pound bombs, the alternate load being one 1,900-pound Mark VIII Mark 10 or 18-inch K-type torpedo in crutches between the undercarriage legs. Internally, the aircraft was equipped with marine distress signals, collapsible dinghy, a camera gun in the starboard lower centre section, and TR4 wireless equipment and crew parachutes. When operating with a torpedo, fuel was restricted to 188 gallons. And it is a gorgeous aircraft. And what I love is that picture in there is this picture here. And to be honest, I got that picture by spending a lot of time playing around with this picture. But we'll leave that out there. So, that doesn't get anywhere. But, at the same time, they're having fun. They've got the B, and still got the Rippon in service. The Rippon is a lovely aircraft, but they need to upgrade it. And the big thing the Rippon has is a liquid-cooled engine, which is a maintenance hog. They are. Liquid-cooled engines require more maintenance. Surprise, surprise. And the air-cooled radial engines have been getting really, really good. And if you look there, you'll see they're starting to talk about the Bristol Jupiters. And eventually they settle on a Bristol Pegasus. So, the Bristol Pegasus is in service and has been in development and is an air engine type which has been on work well before the Swordfish comes on the scene. It's a well-tested system. Yes, they have been improved. But, again, these aircraft are using these engines. So, between 1932 and 1934, 2 aircraft were built. They're the test models. And 95 Rippons are converted at Burruff to Baffins. They equipped number 810 Squadron on HMS Courageous in the Home Fleet, number 811 on Furious, also in the Home Fleet, and number 812 on Glorious in the Mediterranean. Now, I forgot to mention, the Rippon straddles the era of carrier aircraft being organised in flights and squadrons. Now, it gets equipped into number 810 Squadron on Courageous in the Home Fleet, and number 811 in Furious on the Home Fleet, and 812 in Glorious in the Mediterranean. 812 is formed of 460 and 461 flights. 462, 465 and 466 flights form the genesis of 810 Squadron and 811 Squadron. So, 810 and 811 Squadron and 812 Squadron are getting upgraded. This aircraft has a 580 horsepower Bristol Pegasus 2 M3. It has a span of 45 foot 6.5 inch. That's a surprise. It's an upgraded Rippon. A 17 foot 10 inch folded. A length of 38 foot 93 9 3/4 inch. Oh, I had fun putting in the 3/4. And a 12 foot 10 inch height. Their all up weight is 7,701 pounds. Now, all up weight is everything. So that's what the aircraft weighs when it's in the air. First it gets in the air, full of fuel, everything, it's that weight. And that includes a 3,070 pound military load. In other words, of 7,700 pounds, 3,000 is military. Well over 40% then. Carrying us up to 2 crew. You all know the gun arrangement. And up to 1,600 pounds of bombs. 125 miles per hour at 6,500 feet is their maximum speed, and the range is 3¼ hours at 5,000 feet. And that's all out of this. They are a very cool aircraft, and they're very successful. But they aren't anything new. They're a far more reliable, slightly more capable version of the Rippon. And they are critical, because when they're on the scene, they are probably the best in the world. But the pace of aircraft development is quick. If you think about this, in a little over a decade, the Royal Navy has gone through, from one company alone, the Dart, 2 generations of that. The Rippon, 3 generations of that. Now it's on to the Baffin. It started off with the Swift, so that's 4 generations of aircraft. And that's just from one company. And it doesn't stop there, because there comes the mighty Shark. And you can almost predict the squadrons. I'm going to say it's equipped on sort of 810, 820, 821, 822. Produced S-15-33, general purpose spotter, reconnaissance and torpedo aircraft. Combines and amends Specification M.1 and S-930, which have been a torpedo spotter reconnaissance aircraft, with Avro, Fairey, Gloucester, Hawker and Vickers submitting for it. In the end, this comes down to a debate between Fairey, the Gloucester and the Blackburn aircraft. The Fairey is the TSR. The Gloucester, there's no point really worrying about it too much. It becomes down to a straight-out shooting a match between the Swordfish and the Shark. The Shark is powered by an 800 horsepower Pegasus 3, although it does have options for an improved Pegasus, like will be fitted into the Swordfish. Its dimensions are 46 feet when everything's extended, 15 feet when folded. The length is 35 foot 3 inches in land form, 38 feet 5 inches in sea form, and height 12 feet 1 inch in land and 14 feet 3 inches in sea form, i.e. when it's got its floats under, it's taller. All up military load, remember there was a limit on of 9,000 pounds? Well, all up military load with torpedo is 8 in land form is 8,050 pounds. In sea form, it's 8,610 pounds, so yeah, it's a heavy beast, but it's still under the weight limit by a good few £100, so it's got room for a growth margin. Capacity of crew is up to 3, and it can do all the torpedoes and carries all the guns. Its maximum speed with torpedo in land form is 140 miles per hour. 139 miles per hour in sea form, which shows how much effect the floats have on its aerodynamics versus the weight of the torpedo, because in land form, reconnaissance, its top speed is 157 miles per hour. In sea form, its top speed is 148 miles per hour, and that's mainly because the floats start to try and fly themselves. It happens. If you make them aerodynamic enough that they work in the water, they sometimes decide they're going to go off by themselves in the air. With an overload tank fitted, again, like Swordfish will have, They have, in a land form or carrier flight deck form, they have a maximum range of 1,260 miles. In their normal torpedo carrying land form, it's a range of 717 miles. In their reconnaissance land form, it's normally 829 miles. They're a good aircraft. Between 1933 to 9, roughly 300 aircraft are ordered and built. Roughly. Now, there is a reason that I've put a roughly on this one. Okay? There are stats given in here. There are stats given in other sources. There are aircraft produced in Canada. There are also aircraft which go and serve with the New Zealand Navy. And there are aircraft which are produced as prototypes and converted. And there are aircraft which are produced as rolls for this and then converted into other things. And there is a figure on Wikipedia of nearly 270. There is another figure I found in a book which is very reputable, which is one of the Sturviant books, which is closer to 350. When I went through this, I came to roughly 280 something. So I've put roughly 300. But that's 300 give or take 10%. So I'm reckoning it's somewhere between 270 and 330 would make sense. So Wikipedia could be right. This could be right. That could be right. World War II happens. There are lots of people producing stuff because that's what they've got to produce at the moment, and they haven't been given the designs for the things that are wanted yet. So they're producing it, and it gets sent, and it gets used. Because this equips number 810 Squadron, 820 Squadron, 821 Squadron on HMS Courageous. So she has an entire air group pretty much of Sharks in the home fleet. And number 822 on HMS Furious, also in the home fleet, acting as the comparison ship for Sharks and Swordfish. Poor Furious. And number 705 Catapult Squadron, providing flight support HMS Repulse and HMS Warspite, and as well as other vessels. And that's the really interesting one, because the flight support ships and tugs, for a while, especially when they're trying to put as many Swordfish aboard aircraft carriers as they can, and production of Swordfish really hasn't stepped up as fully as it's going to, well, you look at a picture of a cruiser, and it says, this cruiser is equipped with a fairy Swordfish, and you look at it and go, yes, that does look a little bit like a Swordfish, but that's actually a Shark. Not everything with a Pegasus engine and that kind of radial is a Swordfish. I've had fun with that one recently. So, now we come to the reason I have a lovely leather bookmark in my book. Blackburn Aircraft of the 1920s and 1930s. Reconnaissance, spotter and fighter aircraft. Now, basically, the idea was, can we get a spotter reconnaissance aircraft that is based on the same parts, the same maintenance requirements as our top-of-the-range torpedo bomber? i.e., can we build a torpedo spotter reconnaissance when we can't build a torpedo spotter reconnaissance, but we can de facto build a torpedo spotter reconnaissance from a logistical and technical perspective, because both our torpedo aircraft and our spotter reconnaissance aircraft will use the same spare parts? i.e., we don't get the same aircraft from an operational perspective, but from a logistical and technical support aircraft perspective, we do. Now the Blackburn is as ugly as it is in terms of shape because it has to be, because it's got a huge table and radio, navigational equipment and all sorts of other things stored inside that cabin, protected. But I'm so glad it doesn't become the standard. Its competitor is the Avro Bison, from memory, which is also an interesting looking aircraft. It has a span of 45 feet 6.5 inches, 17 feet 6 inches folded. Its all-up weight is 5,962 pounds, including a military load of 1,293 pounds. You're looking at me going, but it doesn't carry bombs or torpedoes. Why does it carry such a large military load? Because a military load includes all guns, all ammunition, and all equipment necessary to carry out its military duties. Tables, maps, navigational equipment. 1,300 pounds of the stuff, nearly. Excuse me a second. Now, why isn't this aircraft kept? Why isn't the Blackburn repeated? Why aren't more aircraft built like it? After all, battleships are very much the primary killing weapon of ship fighting at this point. Yes, torpedo aircraft are very good. Yes, they're looking at carrying more and bigger bombs, 500-pounders, 1,000-pounders. A 2,000-pounder bomb is, of course, a big part of M130. So why is this not kept? Well, as I said at the beginning, when starting this aircraft is logistically and engineeringly a very sound idea. It uses the same as your same spare parts as your primary strike aircraft, which makes everything nice and useful. But it doesn't offer you anything other than observation and reconnaissance. And honestly, you have other aircraft that can do that, which take up less space. And you have aircraft which can sort of do that role, which can also be used to still carrying bombs and torpedoes. This is where you get the sort of genesis moment for the modern F-35. The aircraft that can do everything. The idea starts back in this period with carrier aircraft. Why? You have limited space. You have a limited air group. You can only bring with you what you can fit in the hangar. Or occasionally park on the deck if you've got a good enough, if you're going to nice enough waters. So every single aircraft counts. The more air capable your aircraft are, the more versatile they are, the better. So this is the thing. The Blackburn demonstrates the utility of the role. We need something to fulfill the spotter function. Yes. It's very useful. Reconnaissance function. Very useful. Airborne early warning, actually, yeah, this starts out being very useful. But the trouble is, whilst it's very useful in those roles, it can't do anything other than those roles. And those roles are all rather passive. You need something that can be proactive as well as passive. So now we have the Blackburn Skua. The Skua is selected by the Air Ministry in competition with at least 4 other designs to meet operation requirement OR15. Yeah! In 1933, a Rear Admiral Henderson is appointed as 3rd Sea Lord. Roughly a year later, the first Fleet Air Arm operational requirements start being issued by the Royal Navy, coming largely written from his largely written, it seems, from the 3rd Sea Lord's office as he's building the future carrier fleet of the Royal Navy. And the first thing he needs is something which is approaching a high-performance dive bomber. As a dive bomber. Technically, the Skua is produced as a fighter dive bomber. Technically. And we will go for technically here. But it's got 4 303-inch forward-firing Browning machine guns with 600 rounds per gun in each wing. And one 303-inch Lewis or .303-inch Lewis or Vickers K gun on the flexible mount in the rear cockpit. Capable of taking a 500-pound semi-armor piercing bomb under the fuselage. And practice bombs on the wings. Plus a maximum speed of 225 miles per hour and a range of 435 miles at 114 miles per hour. Pretty sweet. For an aircraft which is written off quite a lot, they sure did build a lot of them, 192. And they serve in numbers 800, 803 Squadron aboard HMS Park Royal, and 801 aboard HMS Furious. Noticing some numbers again there? Yes. These are squadrons which are used to Blackburn aircraft. They're given Blackburn aircraft. For the first British design of a pure dive bomber, it's a pretty good aircraft. It's also good for reconnaissance. It uses a Bristol Perseus Mark 12, 890 horsepower it generates. In dive bomber form, it has an all-up weight of 8,228 pounds, including 1,488 pounds of military load. In fighter form, it has an all-up weight of 8,124 pounds, including a military load of 977 pounds. So basically, they get rid. Most of the military load that goes is the big bomb. But the weight's still only 100 pounds lighter. Why? Because they take on more fuel and other things as well when they're acting as a fighter. The fuselage was of a full flush riveted Alcad, stressed with skins construction. The wings were also stressed skins construction, built in 3 units, with the 2 spar centre sections bolted under the fuselage. The outer wings were tapered in plan and thickness, having detachable tips. The wings folded from outboard of the centre section and were folded down by latch pins operated by a hand lever and gearbox. The undercarriage was retractable, consisting of a oleo-pneumatic strut with stub axle. The fine and tailplane were metal clad, with fabric-covered rudder and elevators. The cockpit was glazed and fully enclosed, and the gunner seated under a tilted canopy, having access to a wireless compartment. The aircraft was stressed for catapult launching and resting and landing, and the original prototype skuas were powered by Bristol Mercury 9s. Now, one of the questions that I often get when I'm talking about a Blackburn Skua is, why does it have the cockpit shape it does have. Why does the canopy shape of the pilots, why is it so flat, basically? And they do actually have a reason for it. The crew was accommodated under a glazed cockpit enclosure supported internally by two specifically strengthened fuselage frames, which formed a crash pylon if the aircraft turned over on the ground. The pilot was provided with sliding curtain and was comfortably seated over the leading edge of the wing with a commanding view of most forward directions. Controls were conventional, and the stick having a knuckle joint so that the sideways movement gave an aileron control. The rudder bar was adjustable, and large elevator and rudder trim wheels were located on the port side of the cockpit. Basically, the shape of the canopy reflects the engine position and the position of this crash structure. So I do agree, it could have been better designed from many perspectives of aerodynamics, but from the crash perspective, it was excellent. And let's be honest, if you're a dive bomber, then having a crash is something you're going to have to worry about. Skua's greatest success was the classic dive bombing attack which sank the German cruiser Königsberg alongside Stuttgart Mall in Bergen harbour at the very limits of range at dawn on 10th April 1940. The attack was mounted by 7 skuas of No. 800 Squadron, led by Captain R.T. Partridge, R.M., that's Royal Marines, in company with 9 from No. 803 Squadron, led by Lieutenant W.P. Lucy, Royal Navy, which made the 330-mile night crossing from Hudson. By a superlative feat of navigation, all but one returned safely to base, but 11 days later, both squadrons re-embarked in Ark Royal to cover Narvik operations, in the course of which practically all the skuas were lost. Many failed to find the carrier and ditched at sea, others were shot down. 2 were interned in Sweden, and others were abandoned on Norwegian soil, where the remains of one which crash-landed at Aalesund in April 1940, fuselage number B3LL432, dated on 7th June 1939, and probably from sequence L2970 to L2980, was still to be seen in 1968. One skua navigated for the 18 Gloucester Gladiators of No. 263 Squadron from the carrier Glorious to Lake Lesjatskog. Basically, they're a lovely aircraft. But they needed cannon if they wanted to be used as a fighter. And they needed a more powerful engine. Not necessarily a Merlin, but they did need something. It's... if... give them a 2000... give that design a 2000 horsepower engine. Or scale it to take a 2000 horsepower engine and scale it up for that. And you would have had a very good aircraft, and a very different aircraft than the one you did have. It's amazing what a few years of development and peacetime can enable you to get to. But there is something which is slightly more disturbing. And is due to the Roc. Pretty much a Skua, but instead of it being a dive bomber, they've handed it over to Bolt and Paul Defiant. And they've given it a turret. And I will read you exactly why. And it's very navally appropriate, the turret being given to it, but you do have to wonder about it. Designed by G. Petty, the Roc was the naval equivalent of the Bolt and Paul Defiant, whose tactical concept was to bring the aircraft guns to bear in a broadside attacks on enemy bombers. Broadside attacks on enemy bombers. Okay. Maximum speed is actually slower than the Skuas, at 223 miles an hour. It also needed guns in its wing struts. Yeah, the Roc. If it was supposed to be a, broadside attacks on bombers. Beware fads when designing things. Beware chasing the shiny. Sometimes the shiny has good stuff, but sometimes you end up with that. What you really needed was the Skua to be a very good quality fighter so that you didn't need the Fulmar. And the Roc to be a good quality, so the Skua and Roc to be a good quality fighter as well as dive bomber, so you didn't need the Fulmar. For that, you needed to have a more powerful engine. The Roc could have been a very good quality fighter. It's got good makings for it. If you had taken out the turret, taken off the bomb capability from the Skua, made it a single-seater, but left everything else intact, and put in some heavy-duty guns, some cannon and machine guns, on its wings, that might have been viable. But that wouldn't have given you the reconnaissance capability, and it wouldn't have given you the range at night and all the other things you need, which the rear person gives. So take off the turret, but leave it as a two-person seat, probably. So, now, we get to turn to this bookmark. Never play golf with the wrong irons. If it's Clive's Cats cartoon gallery, they do these over the internet. They're quite cool ones. Pick them up when I go to Cornwall. So why do I want to do the Iris? Why do I want to talk about these? Well, A, Blackburn are not just building for the Fleet Air Arm, but reliability is a big thing in aircraft design. When you're a land-based aircraft or an air force and you're flying sea boats or these things, you can afford to go to make sure you have reliability, you can go for a treble engine approach. In fact, that's the entire genesis of the Iris, is we need a flying boat which flies with 3 engines so we can ultimately always rely on it for long-range operations. Because if 1 engine goes, it's still fully capable. If 2 engines go, it will still get home. That's the reliability which is being looked for by operators. And you think about it, to get that reliability, they're going for a 3-engine aircraft. For Fleet Air Arms and air services, who are limited to single-engined aircraft operating off their carriers, and catapult aircraft, amphibians from their mostly single-engined amphibians, from their capital ships and cruisers, it becomes a big issue. You might well not take the next leap in engine power, which can unleash all sorts of options when it comes to monoplane versus biplane design and lift capability, because you're worried about the reliability. But the Iris is cool. The Iris is a long-range reconnaissance flying boat with 3 engines. The 3 self-contained engine nacelles were mounted at a mid-gap on steel struts. The wings were of composite construction with wooden spars, whilst the lower centre plane utilised tubular steel main spars. So much of this aircraft is top of the range and world leading. And they need to be. They need to be because they are going to lead. They are going to lead the Air Force's reconnaissance off the shores, in the UK. But they only built 4 of them. Why? We'll answer as we go on. Next up is the Sydney. Doesn't she look gorgeous? The Sydney is a monoplane attempt. The Sydney is to produce that same reliability. And she's in 1927. She's all stressed in aluminium copper. Duralumin is used. An aluminium copper alloy. And all sorts of things in terms of the various alloys going on here. The main plane was of a deep RAF 30 section. That's an actual standardized design. So the RAF has the standardized designs for what they want these aircraft to look like and space to look like. Powered by 3 525 horsepower Rolls-Royce F12MS. Dimensions span 100 feet. Get that out. It's a 100-foot span. Length 65 foot 7 inches. Height 20 feet 4 inches. All up weight 23,350 pounds, including a military load of 1,442 pounds. Capacity crew of 5. Yet still, a maximum speed of 123 miles per hour at 5,000 knots per feet. So, yep, it would be able to equal the Roc. The Roc could catch it. Came 8 years before the Roc. The equivalent if it had been produced, and they ended up going with the biplane version because that's considered more reliable and safe. And they produce a version that's called the Nile for the for East Africa flying boat company as a civilian sort of airliner. But no, imagine this with 3 890 horsepower engines or a 3 Merlin engines. The capabilities this would have had flying from Singapore for reconnaissance or something like that. It would have been amazing. But no. Why not? Well, there are 2 options, always. There are the Short company, who do very, very nice designs, or there are Blackburn. And the Short, because they managed to get far more of the civilian market, pour that into the military market. And managed to do all sorts of things with that to get an edge. This aircraft is interesting though. This is the Perth, which is aka Iris 6. Ordered in 1932. A biplane of all-metal construction. Now remember Sydney? That was of course a monoplane, but they've gone for a biplane because that's reliable. And these planes are all about reliability and long range. 3 825 horsepower Rolls-Royce Buzzard 2MS. Now, you'll notice if you look down at their speed, maximum speed is 132 miles per hour. So even in biplane form, they could outpace a Roc. And a Skua, well no. They couldn't outpace a Roc, sorry, I keep forgetting. It's 223, not 123 miles an hour. Sorry, I'm being cruel to the Roc. I just feel like they should be able to outpace the Roc. The Roc annoys me. Range, normal, 898 miles at 109 miles per hour. 8 hours endurance. And overload, 1,500 miles at 109 miles per hour, 13.5 hours endurance. Overload. Again, made mostly of alcad and duraluminum. But, yeah, it's also got fabric covered 2-bay main planes. And this is what long-range reconnaissance looks like. But again, only 4 built. Why are only 4 built? Well, there's a reason for only 4 being built. Again, they're trying to keep the company going and involved and interested, but they don't really want to build a lot. The idea is going constantly that what we're doing is we're building these aircraft to keep these companies, to keep this technology going. And in turn, when we need it, we'll be able to rapidly mobilize it. Of course, when war happens, they don't really do that. In fact, the Blackburn think they are passing off production of other things to other groups like the Roc, the Bolt and Paul Defiant, because they think they're going to get a huge order for Bofors. Don't look up the Blackburn Bofors, it's a very big disappointment. For an aircraft company which prides itself on its reliability of its aircraft, the Bofors is a big loss. Anyway, so the Perth is rather cool. And I'll just go back and say, I was sorry earlier, it's 123 miles per hour at 5,000 feet as maximum speed. That is slower still than the Roc, which is 223 miles per hour. But still, that's maximum speed of your fighter. It's just terrible. I'm not a fan of the Bolt and Paul Defiant, and I'm not a fan of the Roc. They could have been very good. 4 decent guns, a slightly more powerful engine, and the wings, and if they really want a turret, and they really are interested, that's really what they think they need. Have a single machine gun turret that goes around and gives you all the firing protection. But anyway, summary. So, this book has a lovely dedication in front, which I put there on here. In tribute to Robert Blackburn, 1885 to 1955. Pioneer Yorkshire aviator and specialist in the construction of aircraft for the fleet. And there's the aircraft which bears his name twice. The Blackburn Blackburn. In this position, fitted with strengthened floats for deck landing capability. So what did they achieve? Blackburn were about reliability. Blackburn were about stability, about capability. And they achieved all that. They were critical for operations, and they are critical for the development of fleet aero. Night flying, all the capabilities that the Royal Navy ends up relying on in World War II would not have been there if it hadn't been for the Blackburn aircraft in service in the 1920s and 30s. The only problem is the Blackburn aircraft in World War II. firebrand comes too late. The Skua is a product of the frenzied engineering going on at the time of its construction and the disputes of command and control going on. What's most sad probably is the loss of the Shark to the Swordfish, pipped there because of the reliability and endurance of the Swordfish and the ease of maintenance, because Fairey take a long look at what the Blackburn have been designing and providing and wholesale nick a whole load of ideas. And yes, it produces a very reliable aircraft, and it's amazing for that, because they fuse the Blackburn ideas with the Fairey ideas. But it means that Blackburn in World War II, what are they remembered for? The Skua? This is another aircraft which they could have been remembered for, but it's stopped. The B-20. Long-range reconnaissance plane. Basically, they're Blackburn's attempts to produce the perfect flying boat. What's the problem with flying boats? Making them monoplane and all these things. What's their angle of attack with for their propellers and their engines when they're taking off? It's the air shape of the flying boat. Everything. Well, they sort it all out. They managed to get the proper height by having these enormous struts, having wings which fold up. So, the supporting struts on the sides, instead don't do that like wheels do, they go up and become the wing edges. And the central float, it folds up into the aircraft as well. It's a really cool design and a really cool what if. So, where else can you find me? Twitter, at AC_Naval History, Patreon, AC Naval History, and Global Maritime History. And I hope you've enjoyed today's video, and I hope you enjoyed the live later today. What else have we got coming up this month? Well, we have the Blackburn Surprise today. We have King's College Lawton Seminar on Thursday. We have Brew Ships on 21 on Leadership on the 11th. All that coming up later in the month. Thank you very much, and I hope you've enjoyed. And this really is a very much a long patrol, so I do hope you've enjoyed it, and thank you very much for those who have watched the whole way through. I hope I didn't bore you at any points.